Okay, last lesson we talked about how to use intercepts to graph linear relations. Now today, firstly, let's have a look at some revision questions, and then we're going to continue today's class. Alright, so this is a Cartesian plane. So firstly, what you have to do is check, do you have all the elements on the Cartesian plane? So x-axis, x, arrows, 0, y-axis, arrows, and y. And then all the scales 1, 2, 3, 4, 1, 2, 3, -1, -2, negative side. So that is a very perfect Cartesian plane. So we can start doing the revision. Alright, so firstly, let's have a look at the first example. So y equals 6x plus 3. Alright, so last time we said for the intercept y to plot graph, so we have to find a x-intercept and a y-intercept. So for y-intercept, what we said when x equals 0. So if x equals 0, y equals 3. So this is actually the y-intercept. So next time, you don't have to do the calculation. This part is the y-intercept. Okay, so the intercept is 0, 3. So we quickly mark on the graph. So 0, 3 is here. All right, so this is 0, 3. Okay, now let's have a look at the x-intercept. All right, so for x-intercept, y equals 0. So y equals 0, we just solve this equation. 6x plus 3 equals 0. All right, so x equals -½ So this point is -½ 0. Alright, so -½ is here, 0. So -½ 0. Now with these 2 points, then I can easily find the lines. Okay, so we just connect these 2 points. Right, don't forget we need to write y equals 6x plus 3. Okay, now this is the first revision question. The next one, let's quickly do this equation again. Y equals x take away 4. Alright, so x take away 4. Just now we said we don't have to calculate the y-intercept because this part is the y-intercept. Okay, alright, so we just write y-intercept is when x equals 0, y equals -4. So that's 0, -4. So 0, -4 is here. And then x-intercept. Y equals 0. So we have x take away 4 equals 0, x equals 4. So the coordinate is 4, 0. 4, 0 is here. All right. Now we can connect these 2 points. 4, 0, and 0, -4. Okay. So this line is y equals x take away 4. Now this is the 2 graphs when x, the coefficient of x is positive. Now let's quickly have a look at this one, y equals -2x take away 3. Now if the coefficient of x is -2, let's have a look at what is the graph like. Okay, so firstly we still do y-intercept. Like I said, you don't have to do any calculation. This one is a y-intercept. So when x equals 0, y equals -3. So 0, -3 is the point. 0, -3. I use another color. 0, -3. Now x-intercept. So x-intercept means when y equals 0, so that is -2x take away 3 equals 0. X equals -3/2. Okay, so the point is -3/2, 0. Alright, -3/2 is here. -3/2, 0. Okay, and this point, we connect these 2 points. So this line is y equals negative 2x take away 3. Okay, now the last one, this is the last chance you do the practice. Number 4, y equals negative 8x plus 2. Alright, so y-intercept, when x equals 0, so this one is the y-intercept. Alright, y equals 2, 0, 2. Okay, let's quickly plot 0, 2. 0, 2 is here. Okay, now x-intercept. When y equals 0, so negative 8x plus 2 equals 0. X equals 1 over 4. So the coordinate is 1 over 4, 0. So it's here. 1 over 4, 0. Now we can connect these 2 points, right, to form a graph. So this one is y equals negative 8x plus 2. Okay, now we plotted 4 graphs, right, and with 6, 1, negative 2, and negative 8 as the coefficient of x. Now we can have many coefficients, so we can write y equals mx as the general form. Okay, m can be any number, can be 1, 2, 3, 4 negative number, and even the fraction, decimal, that's fine. And also we have plus 3, take away 4, take away 3, and then plus 2. So we write plus c. And then we can easily see they are all lines. And then this one is the linear relation. Okay. Now, we can also see the m. This is 1x. This is 6x. That means if the m is positive, and then these 2 lines are increasing. So if m is positive, the line is increasing. And if the m is negative, like this line, negative 8, and m is negative 2, and then the line is decreasing when x is increasing. Okay, so the line is decreasing. Okay, and also we can see the different coefficient. This is 1, this is 6, will give the line different steepness. Okay, so let's have a look. This one, if I start from this point, okay, if I start from this point, now I go 1, 2, 2 steps horizontally, okay, and then if I go up, okay, I can see I can reach this line easily from this point to this point. And then I have to go higher, higher, and higher until here to reach the 6x plus 3 line, which means the coefficient actually affect the steepness of the line. So for the steep line, you will have the higher value of the y steps. Alright, so if I go vertically, this is the y steps. This is the x step. If I have the same x step, and then I should have the higher value of y steps to reach this line. Okay, so we can see that m is very important because m decides how steep the line is, so we call m gradient. Okay, we call m a gradient. Now, regarding to these worksheets, we can see how can we calculate the gradient. Just now I said the gradient is decided by the y steps and the x steps. the steeper line will have the higher value of y steps if the x step is the same. So we can say the gradient, we give the definition. The definition of gradient is y step over x step. Okay. Now, according to the graph we have plots just now, the gradient m can be positive, like that, and can be negative. Alright, so let's write down. Can be positive and it can be negative. Okay, alright. Now, let's quickly draw these two situations. And also we have two other situations. We will talk about that later. Okay, so I just draw a quick Cartesian plane. Zero, x, and y. Okay, so positive gradient, your graph will be like that, increasing. Okay, so that is the positive gradient. Alright, so negative gradient, like 8x, negative 8x plus 2, and negative 2x take away 3. And then the gradient will be like that. The graph will be like that. So that is the negative gradient. Okay? Alright. How can we find the gradient? Now, let's have a look at this example. Find the gradient of this line. Okay, so we always write this down. M equals y step over x step. Okay, we always write like that first. And then we choose 2 points. For example, I can choose this point or this point. It doesn't matter. Let's choose this point. Okay, now I start from here. And then I want to finish to here. Alright. Now from this one, y step. So from this step to this step, we have to go down like that. And then we go horizontally to reach this point. So this is my y-intercept. This is my y step, and then this is my x step. Okay. Now let's have a look. How can we calculate that y step? Now I started from 6 for y, finish at 2. So I use 2, take away 6 is a step that I walked. And also some people may ask, this is negative. Why it is negative? So the negative sign means the direction, because you're going down, so that is negative. Alright? But the step is 4 steps. Alright, from 6 to 2, there's 4 steps. Okay, now I continue from this point to this point, which means I start from 2 and finish at 0. So I use 0, take away 2. Okay, now I explain that again. So this is negative 2. That means I walked 2 steps, but the direction is negative direction. Alright, so to go the left. So to the left is negative. And then we can calculate that is negative 4, take away negative 2. The answer is 2. So the gradient is 2 for this question. Alright, so when we calculate the steps, we always use the end point, take away the starting point, end point, take away the starting point. Okay, now give you another example. So we always write m equals y step over x step. Okay, now we choose 2 points. Let's choose this one and this one. That's 2 points. Okay, so we're gonna go down to here and then go horizontally here. Alright, now let's have a look at y step. So start from here and from here. So I use the end point 0, take away the starting point 3. Actually, I walked 3 grades, but the direction is going down. Okay, now I start from here and from here. So the ending point is 2, the starting point is 0, so that is 2 take away 0. That means I walked 2 steps, and then the direction is positive. Go to the right, so that's correct. So that's negative 3 over 2. And we normally write the negative sign in the front. Okay. Now let's have a look at question C. Question C, we still write m equals y step over x step. Okay. Now I choose 2 points. One point is here, another point is here. It doesn't matter as long as these 2 points are on the line. Now from here to here, let's have a look at my y step. So y step, I do not walk vertically. So my y step is from 4 to 4. And then the x step is, I start from here, I end from here. So that is 2 take away negative 1. And we can see if 4 take away 4 is 0, we don't have to care about the bottom because this is 0. Okay, so the gradient can be 0 if the line is a horizontal line. Okay, so we put that here. Now the line could be horizontally placed. If this is a horizontal line, the gradient equals 0. Okay, alright, now let's have a look at this question. Alright, for this question, we still write m equals y step over x step. Okay, now let's have a look at the y step. Now I choose 2 points, 1 point, 1 point. Okay, so this is, we can see this is 1, 2, 3. Now I start from 3 and then going down, so that is, we can see this 2 take away 3. So for x is always 2 because I start from here and horizontally I didn't walk any steps, so that's 2 take away 2. Alright, and then we can see that is any number over 0. Now according to what we have learned before, the denominator should not be 0. It's meaningless. So we say this gradient is undefined. Okay, now we can draw this conclusion. If the line is a vertical line which is perpendicular to x-axis, the gradient is undefined. Okay, so let's draw this line. So we can draw a vertical line, so the gradient is undefined. Okay, so the gradient can be 0 and undefined. Okay, let's have a look at this example. Find the gradient of the these linear relations. Now the difference of this question and those questions we have done is there's no grade. So you are given this intercept 3, so which means this is 0, 3. And then you are given this point, which is -2, -1. And then we need to find the gradient of this line. Now let's have a look at how can we solve this problem. So we always write m equals y step over x step. Okay. Now we need to find the y step. So y step is from this point to this point. Right. So we go this way down to here, and then horizontally go this way. So we go this until here, and then we go this way to reach this point. Okay, so y step is we start from here and end from here. So I'm gonna use this coordinate to take away this coordinate. Alright, so this one is -2, -1. So the y on the y is -1. And then this point here is -2. That's why this point is -2, -1. Okay, now let's have a look. We start from here and end from here, end to here, so that is -1 take away 3. So we can see we totally walked 3 steps to 0 and another 1 step to -1, so that is 4. But why it is -4? The reason is I'm going down. Alright, I'm going down. So x step, we start from here to the left. So the ending point is -2. And then the starting point is 0 because I start from 0 to -2. So this is 0. So let's take away 0. Now I can check I totally walked 2 steps. Alright, from 0 to 2, -2, that's 2 steps. But I walked to the left, so that's -2. So we continue to write -4 over -2. So the answer is 2. So the gradient is 2 for this question. Alright, let's explain the last question here. Now for this question, we choose 2 points. So you're given this one. So this point is actually -1, 0. And this one is 0, -4. Okay, now we always use m equals y step over x step. Okay, so y step, let's have a look. We start from this point, going down until -4. So from 0 to -4, so we use -4, take away 0. Now you double check 4 steps, 0, 1, 2, 3, 4. And then going down, so that's negative, that's correct. And then I go this way. Okay, I go this way, so that's from -1 to 0, so that is 0, take away -1. Alright, so we have, I walked 1 step, only 1 step here, to the right, so that is 0, take away -1, which is 1, so that's correct. So -4 over 1, the answer is -4. So the gradient is -4.